Hey everyone, welcome back. It's Tavis Leaf Clever, and today we're going to be covering a full understanding of the dynamic symmetry ratios. So this can be a fun and easy demonstration of how the dynamic symmetry ratios are read and understood as you start to combine them in your artwork. So I wanted to use these children's blocks because that'll just demonstrate how simple this can be. And what we're going to be doing is building the shape of certain dynamic symmetry grids that we can use in our art. And you're going to get a complete, full understanding of how to combine these and how to read them and how they relate to your artwork. So let me get the camera a little bit closer to the blocks and we'll start getting into it from there. Alright, so one of the most important things to understand and realize is the square is the building block for all of the dynamic symmetry grids and rectangles. Ancient Egyptians used it to build the pyramids, in fact, and you can actually get quite a bit of construction out of just using squares. There are several different dynamic symmetry grids that are constructed just with squares, and I'm going to show you those just because that's what we have here. The irrational ratios that aren't even, like the root 2, which is 1.414. I'm not going to show you those, but what I'm going to show you is going to give you a basic idea of how to read these ratios and how to combine them with your art. One of the reasons we want to do this is because I've got a whole list of, you can see this list, it's a whole list of canvas sizes, right? And we've got a lot of the same ratios repeating, and most of them do relate to the squares, okay? We have all different sizes, like 8 by 10 up to 24 by 36, so from small to large, but they all relate to similar ratios. So we're gonna cover that in these blocks today. And also camera sensors, those are also constructed with the squares. The full frame camera is a 1.5 rectangle. The 4/3 cameras are a 4/3 rectangle. And then you got the 5/4 film cameras, which is the 5/4 rectangle, or 4/5, however you want to look at it. Same ratio. So I stole these from my nephew, actually. I gotta give them back when this video is done. But so we're starting with the square, and it doesn't matter how big the square is, okay? It could be one square or it can be a big square. But already you can see how this large square is created from all of these small squares. And that's exactly what we can do with our dynamic symmetry grids when we're composing an image, okay? We can create smaller versions of the mother. This is considered the mother because it's the largest. And we can make smaller versions inside of it to help us organize the composition. All right, so let's start with the 1.5 rectangle because that's a really popular one, and it's in the camera sensors as well as the canvas sizes. So I'm going to build this up to make a 1.5. The 1.5 rectangle is read from left to right as 1.5, but what does that mean? It means that it is a square and a half. So here's our square, right? That's 1, and then this is half of the square. See? We've got 2 rows, and we've got 4 rows. 4 rows minus half of that, which is 2, equals 2. So we've got a square and a half. I'm trying to do this. I'm going to do this and repeat it just so you guys fully understand, because this can be difficult if it's not covered thoroughly. So I'm just going to do it real thoroughly. So it's basic. I mean, it looks basic, but it gets more complex, but it's still just as easy. And we're going to use the calculator also. So we've got our 1.5 rectangle, and we can see that it's, we can make it up of multiple squares, or we can reduce these squares if we wanted and still have the same shape, okay? So right now I'm going to show you how to do the super simple math, right? And what we do is we're reading from left to right still, and this left side, it's always going to equal 1, no matter how big it is, okay? If we put this square down here, okay, this is reading from left to right, and then up and down, it's going to read 1. Doesn't matter how tall it is. This left side should always read as 1, as the left side of a square, okay? So 1 by 1, okay? This means this is 1, this is 1.5. And you can see that as we separate these, right? So this should always equal 1. Okay, so now an easy way to figure out with grids or even just these simple blocks, right? I'm going to show you how easy it is with the math. So you take your calculator. Most phones have calculators. You can turn it sideways and you can get a few more functions that we'll use as we're digging into the reciprocals and stuff. But I'll show you how easy this is, okay? So take the number of squares that we have on the bottom row. That's 1, 2, 3, 4, 5, 6. And then divide 6 by 1, 2, 3, 4. So 6 divided by 4 equals 1.5. And that's our 1.5 rectangle. Pretty easy, right? But we can break this down even further. And this is where the major divisions come into place and the themes of rectangles come into place. And I'm going to show you how easy this is. Okay, this is a 1.5 rectangle. But what if we take 3 squares and divide it by 2? That's basically just this shape, right? 3 squares divided by 2. Okay, 3 long, 2 stacked equals 1.5. So this shape is equal to this large shape. Cool, right? And if we look closer, we've got a 1.5 rectangle here. 3 divided by 2 creates another 1.5 rectangle. 3 divided by 2 creates another one, and 3 blocks divided by 2 blocks is another one. So we've got actually 4 1.5 rectangles within the mother. This is the mother, okay? But the cool thing is, we've got 4 in there, but it's still creating this 1.5 rectangle. If that is confusing to you, remember we read the length, okay, from left to right, and the height. We're still gonna read this as 1. This is always equal to 1, the left side, okay? And this is half. Well, if we break this down, we have to look at it individually. We have to look at it individual from the mother. So we've got 1, which is a square, and we've got half, 1.5 rectangle. So some might say, well, since there's 4 together, don't we get a different ratio? Don't we add them up together? No, we don't, because we're still doing the math for the total, and we still get the same ratio. Okay, let me just keep going with this example and show you how simple this math is. Okay, so this was 1.5, right? This is 1.5. Now, you're thinking, or you might be thinking, that if we stack these inside, don't we get a different ratio? What's going on here? So when we stack this on top of that, we get a different ratio, and do you know why? Okay, ignore this. If we stack these 6 on top of these 6, sure, we get a different ratio. Do you know why? Because we're still reading from left to right, okay? We're reading the length. So we've still got 1 on this side, but now it's shorter, much shorter. It's like half shorter. See how short it is? Half shorter. So that means our ratio should be cut in half. So now that we cut it in half, basically, right? So 1.5, we're gonna divide it by 2. Divide by 2. And our new ratio is 0.75, okay? So 0.75 plus 0.75 plus 0.75 equals 1.5. And see how our ratio is 1.5 again? Because what we're basically doing with these ratios, we're just reading the length of whatever shape is here. This length, this has a shorter length than the whole 1.5 rectangle. And then so does this. If we're just reading one stack, that's a different reading as well. So if you want to know what that's going to be, so this was 0.75, right? And that's an easy one. If we want to figure out what the whole stack of 4 is, all we got to do is 0.75 divide it by 3, because there's 3 stacks, equals 0.25. So that means this is 0.25. It's just this stack. So now when you add 3 together, you get 0.25 plus 0.25 plus 0.25 equals 0.75. Pretty easy. And this also, as you can see, we've got 6 blocks. That's our 1.5 stack on top of a 1.5. So, interestingly enough, in the book we cover stacked root rectangles. So whenever you stack a root rectangle, you divide by 2. And you can see it here. That's the reason we divide by 2. You're stacking, and then this part is the other half. So whenever you stack, you divide by 2. That's the basic math. And we just saw how it came from this half. Okay, so 1.5, and we're going to stack it. So divide by 2 equals 0.75. That's our shape here. And if we wanted to do that, 3 divided by 4, 3 divided by 4 equals 0.75. Okay, so now we're going to add the other half to that, plus 0.75 equals 1.5. So now we have our 1.5 again. So that's a visual way to see the math. Okay, all right. Now we can see the square grid and then the 1.5. So now that we know how to divide it a little bit, the square, let me take this away real quick. The square, you can see how it can divide by halves, right? Well, what if we divided this by half? What if we read it just this ratio? We'd still have to read this as 1, this left side is 1, and then this length is how many? Well, we've got 1 on the left side, which basically means 1 square, and then we've got, it looks like another square, right? So our ratio would be 1 plus 1 equals 2. That's our ratio, is 2, okay? So that's the ratio of that one, and the root 4 has a ratio of 2, which means it's created from 2 squares. Now what if we added another one on the side? We've got 1, 2, 3, right? 3 squares. So the ratio is 3. This is still 1, okay? And the root 9 has a ratio of 3, okay? And with your calculator, if you don't understand roots, and I don't expect anybody to understand any of this math, but this visual stuff should be simple. So an easy way to find this out with your calculator is we've got this square root button. So if we type in 9 and we hit this square root button, it's going to give us 3. So that's the ratio of the root 9 rectangle. Root 9 rectangle, which is very long, 3 squares long, and the ratio is 3. Okay, so that's cool, right? We're getting somewhere. 1, 2, 3. Ratio 3, that's the root 9. Okay, so it all relates back to math, but it's simple, simple, simple math. Okay, so what if we take this root 9 rectangle, and remember when we stack things up, we divide by 2, right? So if we stack another root 9 up on top of this root 9, what do you think we would get? We'd have to divide by 2. And by the way, let's just take a quick look before we do this stacking. We'll take a quick look at this root 9. So the root 9 equals 3 squares. 1, 2, 3. But when they're all together, we see something else interesting. Look, 3 squares, 3 squares, 3 squares, 3 squares. So this is actually a root 9 right there. That's the shape of a root 9. Same shape. So is this, okay? So now that you're starting to see the internal geometry of this shape and how it's created, let's stack these and see what shape we get, okay? We're stacking root 9s. Stack a root 9. Okay, we got a new shape. We've got a root 9 here on the bottom, root 9 here on top. And can you guess what shape we have, the new shape? Okay, let's go like this. The square root of 9, right? We did this fancy button over here, was 3. That's the ratio of the root 9. Whenever you stack, you divide by however many that's stacked. If we had 3 stacked, we divide by 3. But since we only have 2 stacked, we divide by 2. So divide by 2 equals 1.5. We've got our 1.5 again. So the 1.5, actually, if we look at it, consists of 2 root 9s stacked. 2 of these. Pretty cool, huh? So that's interesting, right? So we're starting to inch our way to compound rectangles, themes of rectangles, and in chapter 15, we can see, chapter 15, let's see. So chapter 15, we've got subdividing shapes. I don't know if you can see that. We've got simple, 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 just like I'm doing here. This block plus that block minus that block equals that block, you know, that kind of stuff, okay? Real simple stuff. 1.5 plus half equals 2. So 1.5, this is straight from the book. 1.5 plus half, which is 0.5, equals 2, right? And ratio 2 is a root 4. You'll get to know all the ratios eventually as you study dynamic symmetry, but you can always use your calculator. You just enter in a number if you want and push that root button and see what it comes up with. So the root 5 rectangle, you push root number and that's the ratio, okay? 2.236. So the root 4 rectangle, we push this root button and it's 2. So we've got 2 here. So that's the root 4 shape, which is right here, root 4. Okay, so we're getting somewhere, right? The painters and photographers might have heard of the 5/4 rectangle or 4/5, however you want to look at it. It's the same shape. So how we get that is just basically the same way. We got 5 squares. This is exactly how the Egyptians might have done it, okay, to get a ratio. They counted with squares, they measured with squares, all that stuff. So we're going to get a 5/4 rectangle, we stack 5 4 high. So we're going to keep going. So we've got 5 long and 4 high. So that's our 5/4 shape, right? And we can do the math, really easy, simple math. So 5 divided by 4 is going to give us the ratio of this shape. And we're reading from left to right. And this is equal to 1, okay? And what's it going to equal? 1.25. And that's simple to see, right? We've got 1 square and we've got 1/4 of a square. 1, 2, 3, 4, and 1/4. So that's an easy way to visualize this rectangle, 1.25. Now we've got the 4/3 rectangle, so that's going to be equal to 4 on the bottom and 3 stacked. So that's our 4/3 rectangle, 4 and 3. We take this, and we'll find the ratio of the 4/3 rectangle. So 4 squares divided by 3 is going to give us the ratio and the length, 1.333. So it's 1 square and 1/3 of a square. And we can break that down. See? 1 square, 1, 2, 3 equals 1, and then 1/3. That's our 4/3 rectangle. Now, let's see what else we can do. We can take this shape that we have here, 4/3 rectangle, and what if we added another third? This is equal to 0.333, right? If we add 0.3333 and multiply it by 3, 1, 2, 3, we're going to get 0.9999, which is a square. Times 3, that's a square. So 3/3 equals a square, right? So this is a third. What if we added another third to that? So we'll be adding, we've already got 1.333. We're going to add another third to this shape. So all we have to do is add plus 0.333. And what is the new ratio? 1.666. And this is an interesting shape because I'll show you how it breaks down. So this is our new shape. It's got a 4/3 rectangle plus another third, right? And what's interesting is if we look at the shapes, we've got our square, which we knew was there, and then we've got this shape. But remember when we did our 1.5 and we divided 3 by 2 and we got the 1.5 rectangle? It looked like this, obviously. It looked like that. 3 divided by 2 is 1.5 rectangle, right? But now it's turned 90 degrees, okay? So this shape right here, that's actually considered a reciprocal shape because it's rotated 90 degrees like that, right? And I don't want to confuse you, but I'm going to mention something about the grids, right? So when we have the grid and we draw this basic armature, the 2 major diagonals from corner to corner, and then we take a line from each corner and intersect it at 90 degrees. If we were to drop a line from this point, this is the reciprocal diagonal. If we were to drop a line from this point, we'd get a smaller root 4 here, okay? So 90 degrees is a key thing we need to pay attention to because look at this. When we rotate it 90 degrees, we get a different ratio, but we get the same shape. So 90 degrees rotation gives us a different ratio, but it's the same shape. And that's what happens inside of these grids when we talk about reciprocals. That reciprocal diagonal creates the measurement for a smaller root 4 inside of the mother. Okay, not to try and confuse you by talking about grids and things, but let's stick to the shapes. Okay, so now we have the 1, the square, and the 0.66. Okay, 666. If you've seen a lot of scary movies, you might be hesitant on using the 1.5 rectangle rotated 90 degrees.
You make the Lord very nervous.
All right.
I'm burning now.
Take it easy.
Hellfire is burning me, Lord.
He's burning.
Burning me. The beast is alive. He's among us. Clear the streets. The devil is here. Oh!
But, you know, it's got nothing to do with satanic rituals, I promise. The interesting thing about this, right? Let's keep going with this. Okay, so we added a third to our 4/3 rectangle, and we got 1.666, which can be broken down into 1 and then 0.66. But I'll show you on the calculator how we can use this real simple button, okay? Something a third grader can do. So in order to create a reciprocal shape or rotate a shape 90 degrees, all we have to do is divide 1 by the ratio. So our ratio is 0.666, right? So we want to divide 1 divided by 0.666, and that'll give us 1.5, okay? That'll give us this. That's 1.5. Now if we want to rotate it again, we can divide 1 by 1.5. 1 divided by 1.5 equals this shape, right? We know that's true, and the calculator's not lying to us because if we take this square, we got 0.333, 0.333, 0.333 equals a square. And our shape here is 0.666, so that's the shape there. Now an easy way to do that on the calculator, say we want to get this, we want to convert this 1.5 and we want to find the reciprocal of the 1.5, which just basically means the same shape rotated 90 degrees. So a way to do that with math and with the calculator is to take 1.5. We could do it one way, 1 divided by 1.5, which I just showed you. Or we could do it easier if you have this button over here. I call it the reciprocal button. It says 1 divided by x, or 1/x. So all we could do is enter 1.5 and push this button, and it's going to give us the reciprocal ratio, which is this. Okay? Now if we push it again to rotate it 90 degrees again, we're going to get 1.5. When we push it again to rotate it 90 degrees, we get this shape. So it just goes back and forth, and it's like a block tumbling down a hill is just going to keep giving us the same ratio and keep tumbling. Okay? So that's an easy way to get the reciprocal. And let me look at the root 9 real quick. So remember, the root 9 is 3 blocks, right? 9, the ratio of that is we just push the root number button. Okay, it's 3. That's 1, 2, 3. Now, if we rotate it 90 degrees, if we rotate 3 90 degrees, we can do 1 divided by 3 equals 0.333. Remember, we already covered this shape. Or we can hit this button, the 1 divided by x, 3. So get a reciprocal, third, and do it again, and we get the longer shape, because we're reading from left to right. Now, that's the third. And we already saw that because when we add these two together, we can see how it's a third, because it's completing the square. So that's a visual way to see the ratios. Now, this is like the finale, okay? Now that you guys have kind of an understanding, we're going to get into some subdivisions, which is talked about in chapter 15 of the book, and also chapter 6. And we're doing simple, but it can get real complex. But if you use the simple buttons I showed you, all you're going to do is get longer numbers, that's it, that don't break down even. But it's actually just as easy to figure out the ratios, okay? All we're doing is rotating 90 degrees, adding it to a shape, adding simple numbers, okay? That's as easy as it gets. Let's do this. I'm going to build the 1.5 rectangle. So 1.5 is 6 blocks divided by 4. Okay, 6 blocks divided by 4. 6 divided by 4 equals 1.5. That's our shape, 1.5. Let's divide 1.5 by 6. So if we take our 1.5 shape, we've basically got 6 stacks of 4 here, right? 6 stacks in a row. So if we take a 1.5 and divide it by 6, since we've got 6 stacks, we'll get one of these guys, just a 1 stack. Okay? And what will that equal? Let's find out. So we've got 1.5, which is our ratio of the shape, and divided by 6 equals 0.25. So that means each one of these stacks is 0.25. 0.25, 0.25, 0.25, 0.25, 0.25. Easy. 0.25 times 6, because you got 6 in a row, equals 1.5. Why is that significant? Well, let's take our 1.5 rectangle and subtract one of these guys. Okay, let's get rid of this. What do you think we'll have? 1.5 minus 0.25, which is that stack, we're going to get 1.25. And remember what we covered earlier? 1.25 is the ratio of the 5/4 rectangle. See, we've got 5 on the bottom, and we've got 4 stacked. 5 divided by 4 equals 1.25 for the ratio. Okay, so that's a simple way to combine these blocks, add them, subtract them. Basically, you can do whatever you want with these grids. You can create different compound rectangles, different themes. You can overlap. So these also, I'm going to add all these together, but these also relate to the cinematic ratios. So a popular cinematic ratio is 21 by 9. It's a lot longer, and basically it's 21 squares long and 9 squares high to visually see what's going on. That's the ratio. 21 divided by 9, we get the ratio of 2.3333. So that's the cinematic ratio. So all these ratios relate. Now let me do the final finale, the subdivision of a large square. And that way, since you've got a handle on things, right? Since you understand how these ratios are read, we can basically look at this shape and see combinations of different rectangles within it, right? So that means a large square like this, if we sliced it down this way, if we sliced it here, and we sliced it here, along here, it's let's move this. We'll have these chunks, right? And each chunk of the larger square will have different ratios. Okay, let's slice it here, which means we can say this is a root 4. Okay, we've got a root 4 because that ratio is 2. We've got another root 4 stacked on top of the root 4. When we stack those, so root 4 is a ratio of 2, 1, 2. And when we stack, we're dividing it by the number of stacks. Divided by 2 equals 1. That's the square we're seeing, okay? We already saw this shape too. 2 divided by 3, 2 divided by 3 equals 0.666. That's the reciprocal of the 1.5. So if we hit our reciprocal button, we're going to see it's 1.5. Okay, it's just rotated 90 degrees. It's rotated back. This can be looked at as a square, or since it's 3 in a row, we can basically see that it's 3 root 9s stacked. So if we take the number 9, and we find its root number, the ratio is 3. 1, 2, 3. If we divide the ratio of 3, and it's stacked 3 times, so we want to divide by 3, divide by 3 equals 1. That's why we get this square. So that's 3 root 9s stacked, giving us a ratio of 1. Pretty cool, huh? So over here we see the 1.5 rectangle. So 3 divided by 2, 3 squares divided by 2, we can prove that it's the 1.5 rectangle. And if we wanted to rotate that 90 degrees, we would see that it would actually create the 0.66 rectangle, which is the same over here. Since we read from left to right, and the left side always equals 1, we're getting a different ratio, right? That's why we need to understand these ratios. Because we'll see the same shape, but then it'll have a different ratio and be like, what the heck's going on? So that's the fun part about these ratios. And a simple calculator can just give you so much power when you're combining these rectangles together to create a new canvas or figure out what grid you should use on a canvas or an alternative grid for a canvas. In the book I show, let me show you. I go through, in the end of the book I show how to create cinematic compositions with the root 6 grid, and then I also show the photography side of things and the drawing side of things, but I'm going to show you how I did, let me find this. So I talk about how I created this photo, and I'll put it up on the screen, but I created this photo with stacked root 9s, okay? There's a tree, and I took the diagonal gauge that I talk about, I lined it up to the tree, and it was reading as a root 9 diagonal. So, and I knew about the ratios, so I knew I could stack root 9s to get the 1.5 rectangle of my camera and compose the scene with that. So I basically, what we're looking at, we've got the root 9s, right? And then tree, I held up the diagonal gauge. This isn't it, but I have the diagonal gauge I'll put up on the screen, but I held it up, and it's printed on transparency film. I held it up, lined it up to the branch, and this diagonal, the Baroque diagonal, was lining up exactly to the tree that was fallen in the distance. So that's why I used 2 of these stacked to compose the image. And we know that 2 of them stacked equals the 1.5 rectangle, right? Because that's a root 9 with the ratio of 3. And when you stack them, you get the 1.5 ratio, which is used in the cameras. So more power to you when you understand these ratios, and you can get into more complex grids and start to be more creative with your compositions and be more flexible too. It's not like trapping you in a cage where you have to use a specific grid. You can be flexible now that you understand it more, and you can use different variations of grids to complement the diagonals of the scene, like I did in this image. So that's it for today, everyone. I hope that helps you understand dynamic symmetry a little bit more and how you can combine the grids to fit your needs as you're creating a new piece of work or you're shooting with a different camera or whatever. If you have any questions that I can help with about dynamic symmetry or composition, leave them in the comments below, and I'll do my best to dig through the book and see if I can reference anything from there, or just do some research and answer your questions for you and possibly do another video. Thanks so much for all the support. I really appreciate it, and I will see you guys next time. Take care.